Dear students, now moving on to see how subatomic particle, electron was discovered. Let's go a bit back in time. For a long period in history, scientists were of opinion that atoms could not be broken further. But things changed after the discovery made by an English scientist named J.J. Thomson in the year 1897. In his quest to study properties of cathode rays, he discovered that atoms contain negatively charged subatomic particles electrons, thus they are divisible. William Crook, the British chemist, was the first person to pass an electric current through a vacuum. In year 1875 he successfully created a near-to-perfect vacuum in the glass tube sealed at both ends with metal plates. He named it the discharge tube. Okay. Now move forward to see how experiment was carried out by William Crookes. Students, here you must be clear about discovery of electron. This discharge tube experiment was started by William, but later on electron was discovered by J.J. Thomson. So, here is the experimental setup. A gas discharge tube fitted with two metallic electrodes acting as cathode and anode. The tube is filled with a gas, air or vapor of substance at any desired pressure. The electrodes are connected to the source of high voltage. The exact voltage depends upon the length of the tube, and pressure inside the tube. The tube is attached to a vacuum pump, by means of a small side tube, so that the conduction of electricity may be studied at any value of low pressure. Do you think I just rattled down all the points? Don't worry, kids. Before moving on, I would like you to revise again the basic components for this experiment. Discharge tube, kids. It is a gas-filled tube. I want you to imagine it just like a soda bottle. Electrodes, what does it mean? Kids, an electrode is a metallic plate or disc which acts as a conductor for establishing electrical contact. In this diagram you can see electrodes at each end of the tube. The one on the right side is anode and it is positively charged as it is connected to the positive terminal of the battery. Whereas the one on the left side is cathode and it is negatively charged as it is connected to the negative terminal of the battery. High voltage battery to give the electrons enough kinetic energy. And a vacuum pump to reduce the pressure inside the tube. It was observed that current doesn't flow through the gas at ordinary pressure, even at high voltage of 5000 volts. When the pressure inside the tube is reduced, and huge voltage of 5000 to 10,000 volts is applied, then electric discharge takes place, through the gas, producing a uniform glow inside the tube. When the pressure is reduced further to 0.01 torr, 10 to 4 atmospheres, the original glow disappears. Some rays are produced which create fluorescence, which is a kind of glow or shine, on the glass wall opposite to the cathode. These rays are called cathode rays as they were originated from the cathode. The color of the glow or the fluorescence produced on the walls of the glass depends upon the composition of gas. Next you will watch a small video clip in which you will see the shiny rays produced in the discharge tube.
By means of a vacuum pump. A glow is seen on the walls of the glass tube. The bright fluorescence glow is due to the striking of the rays.
I know what you are thinking about. Yes. This is important to understand that, why gases at normal pressure act as insulators. It is because as the gas density is high, and the charged particle collide with large no of gases atom, and lose their energy and cannot move freely and hence don't conduct electricity. Now the second question. Yes, apart from hydrogen, you can use deuterium, noble gases, elemental vapors, etc. Well, William Crook could not establish what electric current or cathode rays comprise and what is moving from negative to positive terminal. But Thomson didn't give up and started studying the characteristics of cathode rays. So, the first property says that they travel in a straight line perpendicular to cathode surface towards the anode. Shadow formation. Second property states that they produce a sharp shadow of an opaque object if placed in their path. For example, you can see, a metal cross is placed in the path of cathode rays in discharge tube, a shadow of metal cross is formed at the end opposite to the cathode. This fact suggests that these aren't rays but fast-moving material particles. Charge of cathode rays. In his experiment, Thomson applied an electric field, and it is seen that they are deflected towards positive plate of the electric field, which shows that rays are made up of negatively charged particles. Kinetic energy. Fourth property suggests that, the kinetic energy possessed by the cathode rays. It is because they raise the temperature of the body on which they fall. They produce heat energy when they collide with the matter. For example, when placed in path of cathode rays, platinum foil begins to glow. Students. Fifth property states that, they have energy and can do work, thus produce a mechanical effect. They can drive a small paddle wheel placed in their path. This shows that these rays possess momentum. From this observation, it is inferred that cathode rays aren't rays but material particles having definite mass and velocity. Next, sixth property suggests that, light is produced when these rays hit the walls of discharge tube. In this specific experiment, they produce a greenish fluorescence on striking the walls of glass tube. Whereas other examples can be, alumina glows red and tinstone yellow. Charge to mass ratio. Thomson discovered their charge to mass ratio. Charge to mass ratio value of the cathode rays shows that they are simply electrons obtained from any other source. The value is given here. George Stoney named them as electrons. In his experiment, Thomson changed the gas used and material of the electrodes. And each time, he noticed that, this ratio of charge to mass is constant and does not affected by the type of gas or electrode used in the discharge tube. This property suggests that they are fundamental particles. It was found that same type of rays were emitted no matter which gas and which cathode was used in discharge tube. It suggests that nature of cathode rays is independent of nature of gas present in the discharge tube or material of cathode. Since all the materials produce same type of particles, it means that all the materials contain electrons. We know that materials are composed of atoms, hence electrons are the fundamental particles of atoms. And yes, Joseph John Thomson was awarded the Nobel Prize in Physics for the discovery of the electron. Soon after J.J. Thomson discovered electrons, the race began among other scientists to uncover the basic structure of an atom. How atom looks like. Where electrons reside. All these questions, later on led to discovery of other subatomic particles, protons and neutrons. However, Thomson proposed one of the historical scientific model of the atom, known as Plum pudding model. At that time, it was known that electrons carry negative charge, and atoms were known to have no net electric charge. To account for this, Thomson knew atoms must also have a source of positive charge to balance the negative charge. He considered three plausible models that would be consistent with the properties of atoms, then known. We will not go into details of all three, but among those, Thomson chose the plum pudding one as the most likely structure of atom. According to this model, electrons surrounded by a volume of positive charge, like negatively charged plums embedded in the positively charged pudding. Just like plums in the pudding. Well, students, what is your opinion on that? Do you agree with the Thomson? Is it the best possible structure for an atom? To know the answer you have to wait for the next lesson. Till then, think about it. Thank you and have a blessed day.